Previously on Backup Power Project. The function of that device is to keep this battery topped off. So if we were to run this battery completely down in a prolonged power failure, I would need to hook up a better charger to bring it back to life. And that's the problem. Some people are afraid to disconnect these alligator clips. Others don't have battery chargers, don't care to learn how to use a battery charger. It's a big objection for some people. So today, we're going to look at better battery maintainer chargers that will overcome all those objections. Now, we've got two of them here. The first is a Viking 4 amp 12 volt 6 and 12 volt charger. This is $40 plus tax from Harbor Freight. And the second is this Anhtzcyx 24 volt. This is actually an 8 amp charger from AliExpress. Now, in order to understand what these are going to do for us, let's review how the system works. Either one of these works great. So here's a backup system. This is the new Jupiter inverter. And here's our battery maintainer charger. I've only got two things plugged into this power strip. We've got a fan going here. Hopefully you can hear it. I'm going to simulate a power failure by turning off the power strip. Fan has turned off. Now the first thing we notice, the LED on the battery maintainer stays on, even though the power is off. And if we look at these little notes here, we're told not to remove these tags. Check the battery voltage before use. Do not use the float charger if the battery voltage is below 12 volts. Don't remove this tag, warning. Obviously, the manufacturer has no confidence in this battery maintainer for use on any batteries that have been discharged below 12 volts. Well, how likely is that to happen when we're using the system? Well, here's how it works. This will turn on and actually work, run all of our stuff until the battery drops to 10.5 volts. At 10.5 volts, this will still be producing 110 up here. Your stuff will still be running, but at 10.5 volts, this sounds an alarm. And at 10 volts, it completely shuts off. I've never actually discharged my battery to that level, but nonetheless, power comes back on. How do you know where your battery is? How do you know if it's fallen below 12 volts? Well, you've got to put a multimeter on it. So let's disconnect this. And this is part of the objection. People don't want to have to do this. So put this on. Make sure that the indicator says DC voltage here, 20 volts on this cheap Harbor Freight meter. Make sure that the probes are in the two lower sockets. I've got alligator clips on them. See how good a job this little maintainer's been doing. Keeping my battery at 12.4 volts. That's pretty good. But if it dropped below 12 volts, we should not be using our maintainer on it. Now, another reason that we might want to replace this maintainer with something better is called self-consume. What I like to better describe as parasitic drain. I'll just connect this back up. The question we want to know is, why is this light on when we're disconnected from power? Doesn't that tell us that the device is drawing power from the battery, and yes, it is. One thing to take into consideration when buying a battery charger maintainer is self-consume, better known, at least in my opinion, as parasitic drain. Now here we've simulated a grid down situation. This battery charger is not plugged in, and yet you can still see that the LCD is running. We can see that the battery is now at 12.4 volts. The ambient room temperature is 26 degrees centigrade. You can see the battery level here. All wonderful, but where is the power coming from to run this display? It's coming from the battery. And this readout is going to eventually drain our battery. Now, in order to measure it, we've brought out the big guns here. I have my Fluke 17B. This meter's probably close to $150 or more. We could have also done this test with a little cheap Harbor Freight meter. The big difference here is that the Fluke goes out to 3 decimal places, so we can very accurately measure the parasitic drain of this display. And we can see right here that it's 26 milliamps. Okay, why is that important? Well, assuming we have a 100 amp hour battery, if we do the math, see if this will work for us. We have a 100 amp hour battery, 100. We want to divide that by 0.026, that would be 26 milliamps. And it tells us here that it would delete our battery in 3,846 hours. Well, 24 hours in a day, let's divide that again. That gives us 160 days. So roughly 30 days in a month. How many months is that? How many weeks is that? Let's divide by 7 days in a week. So we'll divide by 7. That's 22 weeks. So roughly 4 months and a little bit, this battery is dead. Just driven down by this display. And in a prolonged grid down situation, we preferably don't want any self-consume, or we want as little self-consume as possible. So even though it's not listed in the manual, we accurately measure 26 milliamps self-consume on this model. Now, how do we set up our meters to make this test? Well, we have it on amps right here. The black lead is into the black banana plug is into the common socket, and the red plug is over here on the left into the amp socket. Now, if we were using this little Harbor Freight meter, we would get a similar result, except it'd only be out to 2 decimal places. And we would have to put this red lead into the one that's marked 10 amps. We'd have to move our function and range switch, right here to 10 amps, and you can even see the little red lines pointing to this socket. And then we could connect it up exactly the same way as we connected this more expensive meter. All right, so how does that work? Well, we take the red lead from the meter, and you put the red lead to the red battery terminal. Then you take the black lead from the meter and you put it to the alligator clip that would have been at that terminal. And that's it. Now, you don't want to turn the power on when you're doing this. You're just measuring what the self-consume of the appliance is. And you can see we are now draining that battery at a rate of 26 milliamps. All right, let's see how the others measure up. Okay, so first we're going to try this Harbor Freight Viking unit. One of the things that I like about the Viking, and a clear advantage if you have the Viking, is the length of the power of the AC cord. Because you're not necessarily going to be right on top of an AC outlet. I don't know if we're seeing this, but the Viking cord is over 6 feet long, and the cord on this yellow one is about 3 feet long. So, clear winner. Nice long AC cord. Okay. Put the Viking in here. Going to plug it into power. Remember, I still have that power strip turned off, simulating a power failure circumstance. So we have our simulated power failure. We'll clamp this. And what's this? We got nothing. Power is out. We have no lights whatsoever. Nothing. Alright, what about parasitic drain? Okay, so in this segment we're testing the Viking battery maintainer charger, and I've got it hooked up here to the battery. Here's the positive lead. Here's the negative lead. The charger is not plugged into electricity. You can see the cord right here. And we're simulating a grid down situation. Now the first thing we notice, even though it's connected correctly, the display is not on. And that's what happens when there's a power failure. It takes about 2 seconds, and so as not to drain energy from the battery, this Viking completely shuts itself off. Let's prove it. Okay, we'll practice with our meter again. We've got the red test lead plugged into the amp socket. We've got the black test lead plugged into COM. We've got our function and range switch here on amps. This is the position for both DC, which would be this solid line here, and the squiggle is AC. So that's the position for both DC and AC amps. Alright. Now, in order to make our connections, we want to run the red lead to the battery. I disconnected the charger. And then we connect our black lead from the meter to where the red lead had been, so any current flowing through the system will flow through the meter. And we're showing nothing. There is zero self-consume from this Viking charger because it shuts itself off in a power failure. Occasionally we see a little 1 milliamp here, at the end of the 3-digit display. I don't know if that's just atmospheric stuff, some capacitor discharging. There is no self-consume. Okay, let's prove it. Let's prove it another way. I'm going to disconnect the meter. I'm going to connect this back up to the battery. Turn this off because it'll just shut itself off. Okay, meter is out of the way. I'm going to run around and plug in that charger. Okay, I've plugged it into my power strip. Turning the power strip on. And we see exactly how this works. After the power failure, it runs green for a few seconds, checks to see what type of battery it's connected to, and then it will usually run for a minute or two to try to top off that battery. You can see we're already up to 13 volts. It's remembered that we're supposed to be on an AGM battery. That's what this top indicator is. And in normal use, that will go green and shut itself off. I don't expect that it will take more than a minute or two to realize that the battery does not need to be charged. Let this run a bit. Or, for impatient people, we can just simulate a power failure by turning the switch off. That's what I'll do. Simulated power failure. Switch has been turned off. And charger shuts itself off. No self-consume. An absolutely wonderful, great feature that makes this the perfect battery charger maintainer for our backup power system. And no one talks about this great feature of this Viking 4-amp charger. So in that regard, this alone, plus the long power cables that come with this, plus the fact that you get 2 DC power cables. This one ends in ring terminals and has a fuse to protect the battery. So if you put these ring terminals on the battery, I know there are people who are afraid of alligator clips. See, we got alligator clips up there now. So if we put this on the battery with ring terminals, there's no alligator clips to scare people. We have a fuse here to protect the battery from overcharging. And if you wanted to use this elsewhere on a boat battery or a lawn tractor battery, all you'd have to do is disconnect this. This is an SAE connector, just like our solar panels. And of course this would be the reverse. You could take this out and use this somewhere else in the meantime. Really great features. Now, one other thing that should be mentioned, I'm going to turn the power back on. This is a backlit display, very easily seen outdoors, even in the brightest sun. As much as I like this model, you can't see this display because it's not backlit. You can't see it outside in bright sunlight. This is for indoor use only. You can cover your eyes, put it under a cardboard box. If the sun is shining, if it's out at all, even on a partly cloudy day, you cannot see this unless it's nighttime, unless you're indoors. So, yeah, this is a great battery charger. It can bring back batteries that other people have left for dead. It has an absolutely fantastic repair mode, but the 2 things that hold it back: very short cords. You can see the whole cords here in my hand. Very, very short cords. And it does have parasitic drain. Okay, let's get this out of here, and now we'll test our original little Harbor Freight battery maintainer. Well, it's hard to argue or criticize something that's worked so well for me for 8 years. Here's our little Centec float charger. Now, Harbor Freight has at least a dozen models, maybe half dozen models of these. This is the box this one came in. What's quite important is the item number, because these are not all the same. This is the number that works really well. No AM radio interference. Does not knock out comms, works great. If you can still get these, highly recommended. Item number 42292. But here's the problem. Let me take this out of the stand. Power's out right now. In fact, I can remove this. Remove it right from the power strip so that there's no question it's disconnected. And yet, that LED is still on. Where's it getting that power? That power's coming from the battery, and given enough time, that little LED will drain this battery, sure as the alarm LED on your car will drain the car battery of a car that's been put in storage. So let's measure it. Okay, see if you remember how to do this. Practice makes perfect. I'm going to turn our meter on. We're going to put it on amps, which is right here. And this is both on this meter, it's both AC and DC amps because we got the straight line. We also got the yellow squiggle. That's how this one works. So we're on amps. Now the normal position of this red lead would be here for normal electronic troubleshooting. This is where you measure volts and ohms and diode tests and so on. But for amps, we have to move it. And we're going to move it to the amp setting. All right, we're all set up on the meter. You have to remember to move this back when you're done too. All right, that looks good. Now, where do these probes go? Okay, I have to fix that alligator clip. So we're going to disconnect the red alligator clip from the battery. Remember now, this is gone off. We're going to put the red lead from the meter where the red alligator clip had been. This is going to cause the current to flow through the meter. We're going to put the red alligator clip from the device to the black lead of the meter. And so now, current flows through the device back to the battery. And look at this parasitic drain. Look at it. Remember, we're not plugged in. All we're doing is lighting up that LED. And what do we see? That's 33 milliamps. All right, let's do our math. Okay. We have a 100 amp hour battery divided by 0.033 equals 3,030 hours. Okay, so 24 hours in a day divided by 24, 126 days. Well, we know there's about 30 and a half days per month or so, so let's divide that by 30. I got the decimal point wrong, but it doesn't make any difference. It's going to be about 4 months. 4 months and a tenth. So a little over 4 months, this will drain that battery. And in a grid down situation where you're trying to get every last drop of power out of your system, you don't want this parasitic drain, also known as self-consume. So there it is. Parasitic drain, measuring 33 mils. Parasitic drain, we measured 26 mils. Parasitic drain, none. Which one do I want on? My low maintenance, no maintenance system? The Viking is the clear winner. I'm no Harbor Freight ass kisser, but the Viking, for our power backup project, this is a clear winner. So having said all that, Why do I own two of these? I have both a red one and a yellow one. Bought them with my own money. None of this stuff was given to me. And the answer to the question why I have two is because this is the best battery charger I've ever owned. It has a minimum recognition voltage of 2 volts, meaning that you can connect this to somebody else's old, abused, neglected, discarded battery. You could read as little as 2 volts on that battery, and more often than not, this will bring it back overnight. When I got this battery right here, this read 4 volts. This battery right here, 4 volts. It's like brand new now, thanks to that. Now we're in maintenance mode. You can see that it's off. I'm going to simulate a power failure. Let's see how this works. Okay, we've simulated a power failure. And because it wasn't charging in the first place, it stays in that condition. Maybe I have to do this. Okay. Connect it back up. Reading my battery voltage, 13.3 volts. (27°C) is what the room temperature is. We saw this before when we were measuring parasitic drain. So if you buy one of these, you have to know to disconnect it in a power failure. That's what a lot of people are afraid to do. But okay, I'm going to turn the power back on. Watch what happens. Little fan has just come back on. Checking the battery. That took all of 3 or 4 seconds. It saw that the battery did not need to be recharged. It turned itself off. Now, notice that the vehicle mode is incorrect. Didn't remember where we were. So I have to put this AGM gel is where it's supposed to be. So this requires a little bit more maintenance and observation. So if you have no trouble understanding how to use it, if you're not afraid to come to your backup power system and disconnect the cable from it in a power failure, and you know that after, when power has been restored, you'll have to reattach this cable, then this is the best charger I've ever seen. But it's not idiot proof. And you can't see it outside. And the cables are too short. This one, beautiful bright display, backlit, nice long cables. No parasitic drain. It is idiot proof. Let's wrap it up. Either of these makes a great improvement to the backup power system. You can get this locally. It's about $40. When it's on sale, it's usually $30. I paid about $30 for this one. These come from China. It could take anywhere from 2 weeks or a month to get here. I paid $26 for this last one. I only paid about $20 for this red one. I've had this red one for maybe a year and a half, 2 years. This Viking is going to go on my water pump system. This one is going to go on my laundry room furnace system. This red one's staying in the garage for general use. Very short money, very, very big improvement to our backup power system. So I think this is a great purchase. I hope this video helped someone. Hope you found it interesting. I hope you know how to measure things that you might not have known before. And if I bored those people who already know how to do all this stuff, well, This video is really designed for beginners, not for engineers with engineering degrees. So thanks for watching, and we'll see you next time.